So what are maybe some of the, let's say, activities or things you can do to slow down that aging process?
Yeah, so I've been doing a lot of it myself, and I put a lot of research in my book, more than I can talk about here. So there's a lot in there. Chapter 2 is all about how to slow aging and why it works. In part 3, I talk about what I do. So the
Mhm.
things that I do and have done for many years are skip meals.
Mhm.
Intermittent fasting is now fashionable, but I've been doing it for most of my life. Very rarely eat breakfast.
Mhm.
These days, I might have a spoon of yogurt to dissolve some of the molecules that I take, like resveratrol.
Mhm.
But mostly, my recommendation, if there's one thing I could say after all these years, it's eat less often.
Mhm.
We're told by our parents typically or our teachers, don't be hungry, snack through the day, eat 3 meals. In my view, this is wrong.
Mhm.
For kids at school, it's different, but once you're in college, you shouldn't be eating 3 full meals a day and
Yeah.
snacking in between.
Yeah.
You want a period of hunger. Hunger is what gives your body the chance to fight back and turn on these longevity genes. The
Mm.
other things I do, just very briefly, of course, more is in the book, is to not eat a lot of amino acids. I try to
Right.
eat mostly plant-based foods. I will eat meat. Meat's not toxic unless it's smoked or heavily
Mhm.
cured. But fresh meat, cooked meat is all good. Sushi without too much rice, this kind of stuff I don't mind. But
Mhm.
mostly I try to eat vegetables also because I want to protect
Mhm.
the planet as well.
For sure.
I go to the gym. Doing high intensity training is important. You want to be out of breath. You want to run for at least 10 minutes at the pace where you cannot carry out a conversation. You're breathing very deeply. This is very helpful, hypoxia.
Mhm.
Keep up your muscle strength. So I lift weights for about an hour. And then I go to the sauna and I jump in a cold pool to give my body a shock. It's all about making sure your body doesn't become satisfied or complacent. Otherwise, it
Right.
doesn't turn on these genes.
Right, right. Yeah, yeah. It's it's so true that the way you outlined in the book is also that your body is surviving under these very harsh conditions where you're kind of forced to promote its own longevity because yeah, otherwise it becomes kind of lazy and it doesn't have any reason to carry on the genome further. But yeah, the few of the things that you mentioned, like fasting, I'm a huge proponent of that as well. And I actually think it's one of the most effective ways of turning on one of these longevity genes, such as sirtuins and autophagy and so others. So yeah, like I'm a huge proponent of fasting in some aspects, and even yeah, like high intensity exercise, they kind of stimulate the similar pathways as fasting and also turns on sirtuins and so on. So you've done like a lot of research about sirtuins in your lab. So why do sirtuins help to promote longevity and how do they work?
Yeah, so we discovered that longevity is controlled in part by sirtuins. So we discovered this when I was at MIT in the lab of Lenny Guarente, and this is now going back 25 years. And these genes in yeast and in our bodies, they sense adversity. And what we discovered in my lab was about 1999, 2000, is that when a yeast cell is hungry, it will make more NAD. And NAD is a small molecule that sirtuins need to work. It's the
Mhm.
gas, the petrol for these
Okay.
enzymes. And they go out and they protect the genome. They stabilize the epigenome so you don't get the scratches so quickly on your DVD in your cells, and they repair broken DNA. They do lots of things. They control blood sugar, fat, um, cell survival. There's thousands of papers now on this topic. Yeast have 5 sirtuin genes. We have 7 in our bodies. And those 7, think of them as guardians of the body that need to be activated by a bit of adversity, what we call hormesis. What doesn't kill you makes you stronger. And that's largely because the sirtuins and the network of survival genes that they work with, other genes are called AMP kinase and mTOR. These form a protective network in our body, and you can activate them in certain ways that I describe more so in my book.
Hmm. Yeah, that's cool. Um, is there other like any specific compounds as well, or dietary choices that turn on sirtuins?
Yeah, good question. So one of the things that's not very well known, even though we published it in a journal called Cell, which is well known, is called xenohormesis, starting with an X, Xeno hormesis. And this is the idea that when plants are stressed, they make molecules that help them survive because plants have sirtuins as well.
Right.
An example of a xenohermetic molecule is resveratrol, which you can find concentrated in red wine, which is made from stressed grapes and bottled. And so xenohermetic molecules can be found in all plants as long as they're stressed out. And so what I look for are plants that have not been treated very well, plants that have been picked when it's dry or really sunny or even with a fungal infection. And you can tell that those foods are full of those molecules because xenohermetic molecules are colored usually, or at least they associate with color. And so if you have food that's very dark green or red or purple, it's a good sign that they have those molecules in them. And so I look for those. I have a lot of salads if I can. And that's one way I do it. There are other ways you can take concentrated forms of xenohermetic molecules. Like resveratrol, I take, instead of drinking 1,000 glasses of red wine a day, just for breakfast, I have about 1,000 milligrams, or just a teaspoonful in my small yogurt, and mix it around. And that way I can have the equivalent of eating a lot of xenohermetic plants. And I think what's happening in my body is the body thinks that the food supply is drying up or disappearing, and it gets ready for this adversity, even though it's not really happening.
Right. Yeah, like the plant polyphenols are an amazing example of this stress adaptation that makes the organism live longer. Like you said, these compounds, they accumulate in the plant if they're experiencing these environmental stressors such as sunlight or cold or something else. So in a way, you're kind of sending your body the signal that things are starting to go sour, and that the winter is coming basically, and you yourself would benefit from like strengthening itself and turning on these antioxidant defense systems and so on. So it's like a very interesting and a perfect example of how humans like evolved in the past, where they would like usually they wouldn't eat like these berries if they had access to other nutrient dense foods. They would only eat those berries if they didn't have anything else to eat. And
Exactly.
they were basically starving, and that's why like calorie restriction also like works.
Yeah, and people say, well, what about carnivores that just eat meat? Well, there aren't many carnivores that just eat meat. Anyone who's had a pet dog or a cat knows that they will also sample plants for their medicinal properties.
That's true. Yeah. What about since the discovery of resveratrol, do you think that its effects or its promise or potential, has it stayed the same, or do you think that is like somewhat decreased as we now have like new research about these things?
Well, I'm still taking it, and it seems to be not hurting me, hopefully helping. No, we've done a lot of research in my lab, and others have done clinical trials. We have some things that are also helpful that I've added to my regimen. But resveratrol is still a very interesting molecule. Scientists like to debate things, right? So it got a lot of attention, then people had a backlash and tried to disprove things. But we have some fairly recent results that we've published, and some new ones that we haven't published, that say that the lifespan extension we get in mice with resveratrol, mice that eat a Western diet, is working through activating the sirtuins. Now, one way to think about, I mentioned NAD and I mentioned resveratrol. These act together in different ways. So think of it this way: there's a sirtuin enzyme that's protecting the cell, and it needs to be activated. Now you can run, or you can put your pedal to the metal. You can accelerate and make the enzyme go really fast. That's resveratrol. Or you can give it more petrol or gas, and that's NAD. And so the gas, the accelerator, the fasting, and all these other things I do are all designed to keep my sirtuins always in a hyperactive state. And NAD is better in a sense than resveratrol, or at least helps resveratrol, because it activates all 7 of the enzymes, not just number 1.
Right. Yeah, that's pretty interesting that it kind of mimics fasting to a certain extent, or mimics exercise in some aspects of kind of tricking your body into thinking that it is exercising and it's activating these sirtuins. So you mentioned NAD. And the area of research of NAD boosters and precursors is also pretty interesting. So, like, what is NAD and how does it affect aging?
The NAD, how does it work?
Yeah.
Yeah. Well, so NAD is a molecule that we need for chemical reactions in the body, about 500 reactions, and without it, we're not going to live very long. And it became a very boring molecule in the 1990s. But when we discovered that sirtuins were important, Lenny Guarenti, my old lab across the river behind me, discovered that NAD is used by sirtuins. And what we then really figured out was that NAD levels go up and down during the day. When we are hungry, it goes up, full goes down. When we sleep, it's going down, or when we go to wake up, it comes up. So it's essential, and it's changing through the day. And what we have realized is that as we get older, many of our tissues, our body tissues, goes down with NAD. So if I look at an old mouse, for example, it has very low NAD levels. And what we're finding in my lab and other labs is if you raise those NAD levels back up, either to normal, young, or even higher, we have mice that can do remarkable things. We published last year that mice can run up to twice as far by raising their NAD levels back to young. So 20-month-old mice were running like they were 5 months old again. And that we traced to improve blood flow through their muscles, which is something you usually only get if you exercise a lot.
Well, that's pretty fascinating, and yeah, I've also seen some of your research that it's really effective in the mice, like just energy production and feeling more youthful and behaving like a young mice would. But there are like different types of boosting or different ways of boosting NAD, like nicotinamide riboside and NMN. So can you walk us through all of the different types of them?
Yeah, there's a lot of people who sell these products. I want to say upfront that I don't sell anything. I am not affiliated with any companies who sell products, even though if you Google these products, you'll see my name all over the place. So if somebody says that I work with them or makes it look like I endorse them, it's a lie. But I can tell you my scientific opinion. Both molecules raise NAD, NR, and NMN. I take NMN because I have a supply of it in my basement because we made a lot of it. It's more stable. NMN will last longer. NR is a bit more sensitive to the moisture in the air. But mostly they're equivalent. Now, we've done some experiments putting them head to head. We've seen that in endurance experiments, it looks like NMN performs better. But I don't want to get caught up in this war, which is better.
Right.
I'm more interested in trying to understand what the biology is. Now, NMN is more expensive. This is one downside of NMN if you want to buy it. But what I'm focused on is doing clinical trials with different molecules that are hopefully better than either of those. And those clinical trials have been going on now for 18 months. And we know a lot about how much you need to dose people to raise their NAD levels up to about twofold normal levels. And we hope to do a phase 2 efficacy study in a disease next year called Friedreich's ataxia. And this would be, I think, the first, well, maybe not the first, but one of the first studies to test the efficacy. The reason I paused is that there was a study that just came out looking at NR plus pterostilbene, which is like resveratrol. And they saw some benefits in ALS patients, what used to be Lou Gehrig's disease. And so I'm excited by some of these early studies that are showing there might be some benefits in people, not just in mice.
Right. So yeah, it's a new field of research in the sense that we a lot of experiments have to be done, and probably it's a very contextual aspect as well, that it may not work the same way in a young person versus an older person, and the way these molecules react will also be somewhat different. So are there like age differences between people?
Yeah, Sim, you've hit the nail on the head. Is that when we treat young mice, there's no effect, and that makes sense. They already have a lot of NAD. Now, if we exercise them as well, it seems to boost the effect of NMN. But generally, if you're looking for blood sugar lowering or other things, it's the almost. And so that's why a disease like Friedreich's ataxia is something that I am optimistic about, because they have symptoms like old age. They have low NAD, we think, and low energy.
Mm-hmm.
And so the studies that are out there, generally, if I was a scientist, I would try them on the elderly or diseases where energy is low.
Right. Because that when energy starts to get low and a person that can't produce its own energy, or the body can't produce its own energy, then it can't really fight disease either, and it can't fight aging if there's like not enough energy. So there's a fine line between having too much energy and not being able to produce enough of it.
Exactly. And most of the studies so far have been on healthy individuals. Some of them have been overweight, but they're still healthy. I'm more excited about people who really need an energy boost and may already have very low NAD levels. So that's what